Hello. Hello, everyone. Hello. Like, jump scare. No, it changes very suddenly, doesn't it? Like a transition or something. Boo. But hello, everyone. How are we all doing? Can you all hear me and everything? Am I hearable? Am I... are the vibrations leaving my mouth and entering my microphone, reaching your ears? Okay, yeah? Grand. Thank you. Thank you all. Hello. Well, nice to see you all again. Lots of people here today, which is quite exciting. That's good, isn't it? How are you all doing? How's your day been? As people probably going back to school today for the first day. How was your first day back? If so, other people have been back at school for weeks at this point. 2 weeks. Some people I know. Maybe 1 week if you started back. Question about mocks? Oh, yeah. Mocks are stressful. If you want me to give you any advice on mocks, then feel free to ask your questions. I've been through many a mocks in my day, but yeah, mocks are stressful, especially if it's your first sets or your first set of year 11. Then they're very stressful because you're obviously worried about getting into colleges and sixth forms, and you want your predicted grades to be good so you can get into really good colleges. Now is really stressful mine. But good luck with them. Good luck. What about me? Yeah, my day has been really good actually. Yeah, I've just been chilling. Because I haven't had much to do today. Because I normally, when it's half term, I have loads of lessons. Like I teach during the day and stuff. When it's half term, but everyone's back at school now, so I had nothing to do this morning. So I've just been chilling. Got some finance stuff done. I scripted some stuff. Yeah, it was quite good. It's quite good. And I have a mock exam in RE on Wednesday. I used to love RE mocks. I don't know if it's still the same. All the question papers were all like the same layouts, so you could kind of like not really cheat the system, but you can kind of get around it if you knew how to just write the exam paper. I guess that's the same with everything. But then again, I was also raised a Catholic, not still a Catholic, but had been to Catholic schools my entire life, so I knew quite a lot already about the Catholic faith. So I didn't have to like learn anything new. We did Catholicism with. What else did we do? Islam. Apparently they're quite similar. I don't know. I don't remember much of it, but yeah, it was interesting. Oh, all the chats just suddenly popped up in the screen, which is quite funny. So I don't know who's put them there. Not me. But anyway, moving on. Yeah, it's going to be normal. It's really hard. Yeah, it's tough in year 11. It's like everything's all at once, isn't it? Because you chill for like all through high school, like all through your school life, you've been chilling basically. Unless you're like the 11 plus, and which is quite stressful. But all through your life, you've been chilling, and then suddenly it's bam, first dose of exams, which is very stressful. You don't know how to deal with them yet. It's your first set, obviously, so you don't know how to cope yet with exam stress. So it's meant to be hard in year 11, not designed to be easy. You have to do RE GCSE if you're not in the Catholic school. I mean, it's good. I liked RE GCSE. It teaches you like critical thinking and things, I think. It teaches you to be, I don't know, because I didn't think Islam was like Catholicism, but so you learn that it kind of is in some ways. Like all religions are quite, in some ways, are quite similar. Oh, not in all ways, but in some ways. And it's quite interesting. I liked RE in school. I didn't pursue it. I didn't do it in like A level or anything, but I found it quite interesting when I was in school. Got mocks in January. Yeah, people have mocks in different times. My brother's got some. He's in year 11, my brother, and he's got some in like 3 weeks, I think, round about. Science mocks in January and some in maths. Yeah, well, good luck. Good luck with those. Maths, all I recommend is doing those are past papers. Past papers are just for maths. You can't really get much better revision than a past paper. It's doing past papers and then going over what you got wrong, like using like Maths Genie and like MME and Physics and Maths Tutor, all those places where you can get questions from. Just going over the things you got wrong. That's all there is for maths. Science is more complicated. You have to like learn stuff for the sciences. Maths is all just practice, but science you have to do like know things. In my school, I always called ethics. Oh, fun. Fun. Do you have to do like a GCSE in ethics, or is it just like you used to have PSHCE in like year 7 through like year 9. We stopped it when we went to GCSE, but you actually do like a GCSE in in ethics, or is it like just a kind of thing you do on the side? Not everyone does a GCSE in RE. I know some people just like don't do it. They study RE, but they don't do a GCSE in it. Other questions you've had to do for the exam board or for all Bramble mods in general? Just for all of them. Well, maths isn't really like isn't really one or the other, because most maths is similar. The only really difference between like AQA and EdXL is AQA tend to ask more wordy questions, whereas EdXL asks them a little bit more straightforward, but then again they are a bit harder. So it's kind of for everyone. In this PowerPoint we've got questions like AQA and OCR. So we do both. We're going to do both interchangeably. But I mean, maybe have a look at one. If we don't like have if you are revising, feel free to do like another paper from another exam board and stuff. They're not much different. Are the mark schemes the same? Yeah, pretty much, yeah. And there's not much different between the course content and everything like that. Just it's a little bit harder. But then AQA lays it out a bit more complicated. So it's kind of like, it kind of like balances out, you know, with the harder maths, but then harder, you have to like actually think to like be like what on earth are they talking about, kind of. We're gonna start soon, don't we? Maybe like quarter past, we're gonna start actually doing some maths. We're just doing averages and box plots, cumulative frequency graphs. So we have got quite a lot to get through, but it's not anything that's, well, I mean, it is tricky. It's tricky stuff, but it's stuff that's always kind of the same. So we're going to go through the questions that are very common, come up in all the exam boards. Very, very common. And it's all like, once you've done one of them, it's like the same stuff repeated. So I'm going to show you kind of the kind of stuff they ask that comes up like all the time, essentially. Like when they ask like a box plot, they always have the same things about a box plot. When they bring up averages on the high paper anyway, they always ask the same thing about averages, you know. So I'm going to show you like what type of questions come up like all the time. So don't worry. I'm not just going to sit here and ramble all day. I will eventually do some maths and such. But yes. Yeah, AQA is tough. AQA is challenging. I much prefer EdXL than AQA. AQA is it is my favourite exam board to teach and to do. So I mean, a lot of each paper content isn't told. Yeah, past papers are really good. I think I much prefer doing past papers for any maths revision. I think doing past papers is the best revision for maths. I don't think there's anything else that's really, I don't know. Maybe unless you just do targeted questions, but then you have like internal bias of which ones you want to do. You end up never doing the stuff you don't want to do. And in past papers, they kind of just throw it all at you, so you can't pick and choose what you do and don't want to do. If you do past papers and you notice over and over again, say you're missing questions like trigonometry, you know, like you've missed one question, then 2 questions, then 5 questions in trigonometry, so you can't really escape what you don't know, essentially. But if you just look at just questions, then you can just pick and choose what you want to do, and then you'll just end up not doing the stuff that you don't want to do, essentially, if that makes sense. You just kind of like cherry pick. So that happen all the time. People just keep on doing the things that they like want to do, essentially, or you'll start with doing stuff like oh, I'll do stuff that's really easy first and I'll do the really hard stuff later, and then you like later never comes essentially. So I think past papers are the best way, because then you can't kind of hide from the things you don't want to do. You have to do them, essentially. I think that's my kind of suggestion, is past papers. They're really, really good. You do a lesson when you go through past papers. I can't, unfortunately. Maybe one day. Obviously, if you look in the description, there's like a survey. So for these live streams, I teach maths pretty much all day, every day, so I can do anything, right? But they asked me to submit what I was going to do. They have to approve it and stuff with their syllabus manager things, to prove that to just make sure that I'm doing things that aren't irrelevant and things. But if you would like it to be the case where you come into session and then ask request things, then let them know, because that'd be really handy to know where what we could improve on, and then we could improve on doing things like ad hoc, which I would love to do. I just can't do for these sessions. And who knows, may do them again. If most of people want me to do them, then I will do them some more after they finish. I think there's 10 sessions overall. This is the 5th one, 5 more roughly. Give or take maybe 1 or 2, because I can't count. But I try and count on the spot. But I think there's roughly 5 left. But they might do some more in the future. So if they do, then they'll look at suggestions and what the feedback was to improve them next time. So I would love to. I love doing past papers. They're really fun, but fortunately not right now, unfortunately. AQA maths and NXL maths, so it's well, I can't show you, actually. I might be able to show you actually in a second. I can show you because the font looks slightly different, essentially. So you can see it in the fonts, which we'll look at when we do exam cloud questions. But if you log on to Maths Genie, just the words Maths Genie in one word, and you go into their exam paper section, you'll be able to see there's a section for AQA and for EdXL and for OCR, and you can look at the front cover. You should be able to notice your own front cover, be to spot it, and that's how that's the difference. And AQA have 30 questions, and EdXL have 20, there's another way you can tell the difference. AQA have more questions in them, but they have a lot of like multiple choice, so it's like less intense, because edX don't have multiple choice. Grade box plots are like a grade 6, 7-ish, roughly. So it's not foundation box plots, but we are going to do averages, which is foundation. So we're going to do a bit of both today. Doesn't matter, depends on how I guess sustainable you want to be. I used to print them off when I was in school. I think it's like gives you more like a real feel for it. But if you care much about sustainability, then we're going to start in a minute, Ravenite, don't worry. Then I would maybe like do them online, like I do like in the PDF editor or something, if you care about sustainability. But if not, then just print them off. Then you have them all stored. You can look at them. That's what I used to do. Or just look at the paper online and then write it out on a piece of paper. I guess that's the same thing. So yeah. We're going to finish roughly at 6. I want to get through what I want to get through. So if we finish a little bit past 6, it doesn't really matter. We're going to finish roughly at 6 o'clock. But we may have a ramble, like a chat afterwards as well. Which I like chatting. I think it's interesting to see what you guys have to say, what your questions are. That's I guess what I'm here, isn't it? A, to teach you maths, and B, to offer you advice and stuff, because I do obviously teach math and sciences day in, day out, so I know quite a lot about it. So I guess I'm here to not only teach you some stuff, but also to answer all your questions and things. So that's why I like to have a bit of a chat before and after. So I'll finish, I don't know, last week it was like 6:15 roughly, so maybe like that again. But then we won't do maths for the whole of it, we'll just do chatting at the end. So if you do wish to leave and don't wish to hear me ramble, then you're welcome to leave at like 6 o'clock. Cool then, okie dokie. Are we ready to get started? Averages, box plots, and cumulative frequencies. Fun. Let me then move on. Let me grab the change screens. Move it to showtime. That should work. Yeah, there we are. Cool. Can we see the PowerPoints? Has it moved? Can we see it? Just waiting, because I never know. I can never tell. It looks good in my Streamlabs, but I don't know if it's actually the PowerPoint. Yes, thank you very much. Okie dokie then. So the thing we're going to start with is averages. Just a nice simple average question. What is median? What is mean? What is mode? What is range? All those lovely buzzwords that you've been hearing for many years now, since probably like year 6, right? All those lovely buzzwords. Then we're going to look at some more kind of mid questions, so ones that are going to be right at the end of foundation, but right at the kind of beginning-ish of higher, maybe like between like around question 7 on the higher paper, but then after question either question 17 on the foundation paper. And then we're going to look at spark plots and cumulative frequency, and both of those are just higher paper exclusive, so if you are foundation, I do apologise, but it might be interesting just to see it anyway, just for fun, Let's get started then. There we are. Okay, averages. Lovely. So, can we see that? I'll make the question a bit bigger in a second, but I'll read it out first. Feel free to hold your phone closer for now. But here is a list of numbers: 14, 19, 15, 20, 11, 14, and 19. Find the range, work out the median, find the mode, and calculate the mean. So I'll let you have a little go at that for whoever wants to. I'm going to make this a bit bigger so you can see the numbers a bit better. I'll just zoom in a bit. Just like, there we are. Should be a bit better for you. Hopefully that's good. So yeah, there we are. So if you are confused, if you have any questions, if you're a bit unsure about what one of the words mean, feel free to ask. But if not, let you have a go, see what you get. So first up, can you please work out the range for me? And if you're unsure about what the range is, feel free to ask and I can explain it. I'll explain it when I do the answer anyway. But what is a range and how do we get there? It's looking good so far. Looking good. I'm going to do it myself. Make sure we're all right. Let me double check. Yeah, we're all looking good. I got the same thing as you guys did. Perfect. Well done, everyone. Okay. And then, absolutely right, so the range, for those that don't know, so range is always the highest number, take away the smallest number. So the highest, take away the lowest. That is the range. Highest, take away lowest. And that, in this case, is going to be 20, this one here, take away 11, this one here, which is indeed 9. Perfect. And then can you all have a go at working out the median? You may need some paper for this one. And just to jot some stuff down, unless you can do it in your head, in which case it'll be very impressive. I don't think I can do that in my head. I'm going to need some paper. I'm going to use some now. But feel free to get some paper if you need a second to grab some, a calculator if you wish. A piece of my booklet and a little spider ran out from underneath it. That's a bit spooky, isn't it? Let you have a go. So what is a median? While I write down these numbers and put them in order, what is a median? Actually, I might as well do it on the board. What is a median? What is one? What is a median? For those who don't know, what is a median? Yeah, perfect. As Mikhail said, it is indeed the middle number. Perfect. Middle number after what? Because it wouldn't be the middle number in this case, because that one looks like 20 to me. Not 15. 15 looks a bit to the left. So what is the middle? It's always the middle number? We have to do first to get the median. I have to put them in ascending order. Perfect. Yeah, so I'm going to put these in order. So we've got 11, that's done. And then 2 14s, done and done. And then we've got a 15. Yep. And then we've got a 19 and a 19. Yep and yep. Then we've got a 20. And then we're going to go through and cross. Oh, we can barely see the 20. Doesn't really matter. You can tell it's a 20. Then you're going to go through and chop them all off at the edges. So we're going to get rid of 11 and 20, then 14 and 19, 14 and 19, and then we're left with 15 being the median. So median, put them in order, and then chop them off until you get the middle number. Or you can count them up and half it, whichever number that number is. So you put 1, 2, 3, 4, 5, 6, 7, add 1, 8, fourth number along, 15. That's also how you can do it. Then mode, what are we getting for mode? Perfect. Mode is looking good as well, 14 and 19, because what is a mode? You're all absolutely right with what number it is, what numbers it is in this case. But what is a mode? I think Angel had it a little while ago. Perfect. Mode is most common. Perfect, perfect. Absolutely right. Fantastic. It is indeed. Number that occurs the most. It is indeed. So mode is the most common, which in this case, there's 2 cases of 14. That's going to be a mode. And the 2 cases of a number 19, so that will also be a mode. It's like bimodal in this case. Perfect. So then what about a mean? Mean is the meanest average. This one's a tricky one. Mean is the meanest. So how do we calculate a mean? If we use a calculator, you could use on calculator, to be fair, but I do not wish to do that. That seems like awfully taxing for a Monday afternoon to add up all those numbers. Mean is 16. You should add up all the numbers and divide it by how many numbers there are. Fantastic. It is indeed. We do 14 plus 19 plus 15 plus 20 plus 11 plus 14 plus 19, which is 112. And then that's with the 7 numbers. 1, 2, 3, 4, 5, 6, 7. Divide it by 7. And it is indeed 16. Well done, everyone. Perfect. And that, mean, mode, median, range. So range, highest take lowest. Median, order them, then the middle one. Mode, most common. Mode is most. And then calculate the mean. So mean is the meanest. Add them all up. Divide them by the number that there are. Perfect. Grand. Any questions after all that? Well done, everyone. Very good work. Everyone got them all. Perfect, perfect. What are we all thinking? Do we have any questions about this thus far? Any questiones on any of this? Are we all doing good? Ready to move on? We all happy? I'll have a little sip of my drink. What's mode? Mode is most common. So mode is most. They can kind of sound similar. Mode is most. So the number that kind of comes up most often. So in this case, there's 2 14s and there's 2 19s, and then 15 is only 1, 20 is only 1, 11 is only 1. So those aren't the most. Most common is 14 and 19. Histograms. I can't remember if we're going through histograms. That's a good question. I'll have a look at that at the end. Remind me at the end, because I might be, actually, but I can't quite remember. But let me know at the end. Ask me again at the end, and I'll have a look through my schedule. Blah, blah, blah. Can't talk. Write them through my schedule. I'll have a look through my schedule, and I'll have a look. So I think I might be, actually, but I can't remember when I would be. I think I am. Right. How do I remember them? It's just a case of kind of practice, essentially. The more you do, 'cause it's always the same it's always the same, right? It's always the same definitions. They always mean the same thing. It's just a case of like practicing them, going over and over and over and over and over and over them. And they actually sound quite nice as well, because most, mean is the meanest. That's what I said. This is the one that's really complicated, and I'll divide them. Median is like middle, has an I in it, so you can kind of remember median as middle, essentially. And then range, like highest hit lowest. So there's not really much a way to remember that one, I don't think. And what happens if there's no middle number? Then you look between the numbers. You look between them. So say, like, if there was no, say if I added a number onto here, say if we did 4, actually, you go between them. So say this was in order already, right? It's not in order, but say it was, and we got the median between, somewhere between these. Then you go between them to look at like 17.5. Does that make sense? So these were already in order. They're not, but if they are, and these ones happen to be next to each other, you go in between them to get 17.5 as the median. Hope that makes sense. So if there's no middle, you go between them. That's quite funny, Erin. So Erin's got a way to remember it. Like, you'll read that out when I read it out and butcher it, because I can't see, I can't read very well, but like, you'll read that. Because Erin's got one. So hey, riddle, the median's the middle, add and divide for the mean. The mode is the one that appears the most, the range is in between them. That's quite fun. Akila, yeah, that's the same thing. That's kind of what I did. I know what divide by 2. I just know what's halfway between them. Yeah. So you can either kind of count and figure out which one's between them, or if you can't figure out which one's in between them, I know I've divided by 2. It's the same thing, yeah. I know I've divided them by 2. Or you just find what's in between them. Because 15 plus 2.5 is 17.5, and 17.5 plus 2.5 is 20. It's like just in between. Cool. Well done then, everyone. Let's carry on then. Let's keep it moving. Move on and on. Okay, and then this is more of a higher kind of question. It is tricky, more of a higher one. So it was actually on the high paper, question 7, which is still foundation range. It was still on the foundation paper, but it's right near the end of the foundation paper. So there are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. So this one's tough. Give you a couple of minutes to think about it before I start going through it. Give a bit of a clue. But while I'm doing that, I'm going to look at the schedule. Because Akila, I have done angles previously. I did it for yesterday. Well, yeah, it comes up all the time. I've seen it comes up in AQA. I've got another AQA question next. It's just like this. Edexcel, and it was predicted to come up last year as well. So it was on like all the predicted papers for last year for 2022, and it was predicted to come up. I don't know if it actually did come up or not, but I'm assuming it did. Hence Dr. Frost putting it on. Oh yeah, well yeah, it is from a past paper, so you guys will be experts at it then. Using the active recall to bring it back. And I'll let you have a go at that while I bring up the schedule. So a couple of people are asking about it, so I'll bring that up. And we can talk about that while you're having a go at this. Because I did trigonometry a couple of weeks ago, Akila. I did like triangles a couple of weeks ago. And that's the majority of angles. I don't think we're doing any other angle things, but I'll have a look. Let me grab it. It's in my emails, I think. Actually, no, it's in my hard drive. Hang on, let me have a look. My Google Drive. So yeah, I'll let you guys have a little think. Okay, sounds good, Angel. Yeah, it is tricky, but once you see it once, it's always the same methods in different contexts. So I've seen it with people having a test. I've seen it with like cats and dogs at the vet and their like mean weight. I've seen it with like heights, average heights and stuff. So I've seen it in a couple of different places. It comes up all the time. And Sokotoa I've actually already done. So Sokotoa I did a couple of weeks ago. So the video will be on YouTube. It'll be called Trigonometry. It'll be on the YouTube channel for my tutor. If you look back on my video of trigonometry, scroll through to like, I think probably like 20 minutes in. We'll have done Sokotoa around there. So I have done it already actually. So we can't do it today, but we have already done it. So let me have a look. So yeah, I'll let you have a go at this question while I grab that out. So yeah, I did trigonometry on the 24th of October. And then let me have a look. So just in case you're all wondering, probability is the one next week. Ratio is the week after. Straight line graphs and inequalities is the week after that. Then we're doing angles in parallel lines and circle theorems. That's going to be the 5th of December. And then simultaneous equations, the last one on the 12th. So we are actually doing angles again. Unfortunately, no histograms. Unfortunately, I thought we might be doing it, but unfortunately, no histograms. But again, if you want histograms, maybe put that in the survey. Because if enough people want more, then might do some more of them. Who knows? Maybe after Christmas or something. But I'll talk to my tutor. So if you do like them, you do want more of them on different topics, then let them know. Cool then. Okay, let's make a start then. I think people are a little bit confused because it is really tricky, this kind of question. So let's have a look. Let me read it through. So there are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Okay. So what we need to do here is it's kind of asking us to think critically about what a mean actually is. So a mean, as we saw earlier, is all the marks added together divided by the total number of people, right? So let's kind of start putting that, kind of forming an equation from it, sort of. So mean mark for all the class is 60. So they must have gotten that by doing 60, or equals 60, adding up all the scores, so total of scores. So adding up all the scores of everybody and then dividing it by the total number of people, which in this case was 30, right? Does that make sense? So they must have gotten 60 by adding up all the scores of everyone, then dividing it all by 30. Does that bit make sense? How they've done that, or how I've done that, using what they've told me. So they must have gotten 60 by adding up all the scores, then dividing it by 30. That's how they must have gotten 60. Yeah, making sense? Perfect, Zara. Yep, okie dokie. And then from this, I can work out the total of all the scores. And it is how I can do that. How can I work out the total score of like everyone added together using this equation? How can I do that? Any ideas? How can I work out the total score? Perfect, yes. Just going to rearrange this equation. And it was a divide, I'm going to times that instead, times that up there. So it was a divide, and I'm going to times it instead. Do 60 times 30, which is 18 with a 6 and the 3, and then 2 zeros, so 1,800. So all the scores of everybody, all added together, was 1,800. Okay, that's the first thing we're going to do. And then from here, I can kind of do the same thing again, if we can see. The mean mark for the girls is 54, so I can kind of do the similar thing again. So I can do mean mark, okay, that was 54. Oop, I'll move it from there. I'm going to cover my face soon. 54. And then they must have gotten that by adding up the total score of the girls. So all the girls' scores all added together, then divided by the number of girls, which was in this case 20 girls in the class. Then from here, we can again work out the total score of the girls. Times that by that. And then, bam, that's going to get you total score of the girls is equal to 1080. Okay, and then that is that. What next? I wonder. I'll let you all ponder that for a second. We're very nearly there now. We just need the mean mark for the boys. The total score of everyone all together, and the total score of just the girls. So what are we going to do from there? Yeah, that's right, absolutely right. X mile X. It is indeed take them away. Perfect. Because if we take them away, that's going to be the total score of just the boys, right? Just the boys. So what we're going to do is, absolutely right. So total score, which you can still see that, yep. Score of the boys. That is going to be 1,800, take away 1080, which is something or other. 720 maybe? Don't trust myself enough for that. My calculator says with me all time 720, isn't it? I need to trust myself more. 720. And then how do we go from that to the mean mark for the boys? How do we go from that to the mean mark for the boys? So the total score for the boys. So the total for the boys is 720. We are going to divide by what though? I wonder. We're going to divide by, yeah, divide by 10, because that is the number of boys. We know that the mean is total number of everything added together divided by the number that there was. And there was 10 boys that got all these scores. So divide it by 10. So the mean mark for the boys was 72. And that is that. That was the answer. I think that was about 4 marks in the exam. Correct me if I'm wrong. All of you guys seem to have done it already. But I believe it was about 4 marks. Maybe 3 on a bad day. But I picked 4. So yeah, that was that. How do we all feel? Now that we've seen it, how does it seem? 3 marks? Yeah, 3 or 4. Maybe, yeah. Now that I'm looking at it, maybe 3. Either or. Change depending on the year, I suppose. Depending on if they needed to add an extra mark in there somewhere. But that was 3 marks, I think, in this case. And yeah, it was the high paper. It could have been on the foundation paper, just right near the end. This was question 7 on the high paper. And normally they kind of link up to that point. Like the first half of higher is like the second half of foundation. But roughly. Give us a couple of questions. Yeah, questions tricky. I will summarize, Akila. So what we've done first is we've been given that the mean mark is 60, right? Mean mark of all the class, everyone in it is 60. So in order to work out a mean, so a mean is, so the total of all of them added together. Like when we looked at these numbers here, right? To work out a mean, we added all these together and then divided by 1, 2, 3, 4, 5, 6, 7 for 7 numbers. So we added them all up and then divided it by 7. So they must have done the same thing. So they will have added all the score from every boy in the class together, then divided it by something in order to get the mean mark, right? Does that make sense? So for the mean mark of all the class, for all the class, they've added every single person's mark up and then divided it by the number of people in the class. So then I put that kind of into an equation. So 60 was then the total scores of everyone in the class all added together, and then divided by this 30 here. That must have been this 60. Does that make sense? So total score added together, divided by the number, must have been the mean. What we did was work out the total score of all the boys all together. So then, to do that, we rearranged 60 times 30 to get 1800. Okay, then we did the same thing for the girls. So we knew that the mean for the girls was 54. They must have gotten this by adding up every score for the girls in the class, like every test score they got all together. And then they must have divided it by the total, which was 20. 30 was from 10 plus 20. That was 30. 10 plus 20 gives 30. That's the number of people in the class. 10 boys, 20 girls. Assuming that's the only gendered people in the class. There you are. No non-binary folk in the class or anything like that. So then they multiplied this by this to then make the total score for the girls. So then total score for the girls was 1080. Total score for everyone was 1800. Then it just leaves the boys like in the middle. So then they subtracted these. That gives the boys' score there, 720. So the girls all together got 1080. Everyone all together got 1800. And they subtracted those, 720. And then to work out the mean, all the scores together, which is 720, divided by the number of boys, 10, and that gave us 72. And that's that. That's a summary. It was quite tricky. Let me have a little look. That's as hard as it gets. Well, this is kind of the only question they really ever ask. It's just this over and over again for averages on the... So foundation paper gets a bit easier than this. On the higher paper, it's just essentially just this. For averages, they ask just this. Just different context. Just this same question over and over again, essentially, on the higher paper. And then... Does that all make sense, everybody? We'll have a look at another one that is essentially exactly the same as this. We'll look at... There's another one that I like, this one. It's essentially exactly the same in this for the higher paper for averages. And it is essentially, as you can see, sort of the exact same question. So it really doesn't vary very much. So we'll have a little look at another one. So, during a day, 20 cats and 30 dogs visit a veterinary practice. The mean mass of the cats is 4 kilograms. The mean mass of all the dogs and the cats is 10 kilograms. Work out the mean mass of the dog. So as you can see, pretty much the same question, just with a different context and different numbers. So let you have a little go at that, because it is essentially, as I said, the same question. It's just different context. So it's the same working out if you remember how to do it. I'll give you a little second to have a little thinkaroo about it. This is about grade 6. Okay, around about grade 6. Yeah, question 7 is about grade 6. Maybe top of a 5, possibly. Depending on the context and how easy the numbers are to work with. But it's roughly about either top of grade 5 or a grade 6. So hence it could be on the foundation paper, which is top of grade 5. And yeah, we do it in the reverse way, much like we did before. So figure out what the mean actually means, and then what would we put in to figure out the mean averages, and then work backwards from there. Let's have a look. So not quite, Raya, not quite, because that's with mean masses. So, because mean masses don't work like masses normally do. So not quite, because mean is just an average. So not quite, unfortunately. And we'll go through the answer in a second. So sit on your answer, double check, triple check, then we'll go through it together. So sit on your answer for now. Maybe double check, triple check you're working like you would in an exam. And then we'll go through it. So, first thing we're going to do is use the equation involving mean mass of the cats. It's the first thing we're going to do, because that's the first sentence that's kind of there, other than this. So, mean is always the total over like the number that there are. Right, mean equals total divided by like the number. So the mean in this case for the cats was 4. Total, don't know how much all the cats weighed all together, so we don't know that. But the number of cats, we do know that was 20. Yeah, so we do know that, that's 20. So the total weight, or mass, I should say. Same thing in maths, different in physics. So total mass, that's going to be 4 times 20, which is 80 kilograms. So all the cats added together, all of them added up, it weighed 80 kilograms. And then what we're going to do is same thing, but for the mean mass of all of them, all the cats and all the dogs. So we're going to get mean, which is 10, is equal to the total mass of all the cats and the dogs. So total of cats and, gone behind my face, we can roughly see dogs down there, over the sum of all of them, so all the cats and all the dogs that were in the vet practice, and that is 50. So then we are going to do 10 times 50 to get 500. So the total weight of all the cats and all the dogs, so total mass of all the cats and all the dogs was 500 kilograms. Are we all getting this the same as I am? Are we all getting this the same as I am? Hopefully. I haven't made any mistakes. I'm prone to mistakes though, I haven't made any. But I don't think I have. And then what we're going to do from here is then figure out, that's total mass of, probably put cats in there, total mass of the cats, that's total mass of all of them, all together. And then we're going to do 500, which is total mass of all of them, take away 80, get the total mass of just the dogs, that's all of them, that's the cats. So what's going to be left over is the dogs. And then we're going to take those away, 500, take away 80, which is, pencil maths, not my strong suit, 420. Okie dokie, 420. And then that is then the total mass of all the dogs, right? So then we know that the mean equation is the total mass of all the dogs, which was 420, divided by the total number of dogs, which was 30. In the question, says it just, oops, daisy, is it just up there? I'm giving you a whiplash, hopefully it's not too quick. And then I'm going to divide those to get 14 kilograms. So well done to whoever said that. As you can see, it's the same question over and over again, just different context. They ask in AQA, EdXL, OCR, WJEC. You didn't tell me it was 14. I didn't know it was 14 at that point. I was stalling till we did it here. But you are absolutely right. Absolutely right. Perfect. Well done, everyone. So everyone that said 14, everyone that knew it, well done, well done. So now you know how to do that. So when you see it next time on either Dr. Frost Maths or in another exam paper you may do, because of all the time you'll know how to do it now. Comes up all the time, all the time, all the time. It could be either or Keeler. Most things on maths can be calculator or non-calculator. It's not really a set list for things like calc or non-calc. Apart from, obviously, because things can be left in terms of pi or not in terms of pi for things like the calculator papers. Trigonometry is normally calculator, but then you could have exact trig, which is non-calculator. So I'd always assume that everything can be on either paper, like any 3 of the papers. So it could be either calc or non-calc. But I think the first, let's have a look. That was paper 1 for EdExcel, AQA, sorry. That was also paper 3, which is, but you can see the numbers are a bit more awkward in this case. So if the numbers are really awkward, it'll be calculator. And this one was paper 1, so this was a non-calculator one. So, as you can see, the math isn't overly complicated. It's just a bit of times in and then some subtracting. It's just the method and knowing what to do. That's the tricky part. So the actual calculations themselves, if you know what you're doing, aren't that bad. It's just a case of getting there. That's the tricky thing. Right. How are we all doing then? Doing good? Ready to move on? I'm thinking time for box plots. Essentially, it's just this same question, as you can see from the AQA one. This one, same thing. Over and over again. Same thing, same thing, same thing. Actually, if you ask me that at the end of Keeler, I'll put that down. I don't want to do it right now because we're running out of time. I'm a bit nervous about that. So we'll do it at the end. I will tell you a method to remember the exact trick value. Just remind me like when I finish the maths today. And I will tell you. There we are. Cool then. Let's just move on then. Box plots. Box plots, box plots, box plots. So box plots are higher only. So if you're doing foundation, I do apologise, you won't see these in your exam. But it's interesting, all the same, to see what it's life's like for the higher paper students. It's not actually that bad at box plots. I quite like them. They're always the same kind of method. You just have to learn kind of what number you need and where you put them and such. But anyway, so the times in seconds of 15 students running a race are recorded below. I'll make the numbers a bit bigger, don't worry. Draw box plots for this information. So obviously you guys can't draw it off the grid, but if you guys tell me what to put numbers where, I will do it. So what do we need to calculate for a box plot? You have a little think. So there are the numbers, made a bit bigger. What do we need to calculate for a box plot? There you go, I made it bigger. It should be to see now. Hopefully. Made them bigger. I know. Because it looks really small on mine. Because normally you should also be able to see this screen. Because normally students go, it's the same letter space as what's normally on like my tutor. So the student normally goes up here and there's that little grey box here so they can see the same screen I can. Let's have a look. Mean. Not quite a mean actually. Not quite. We don't really need not quite mean a mean. A different average is needed actually. Actually, I guess you could use a mean, but I never normally use means though. Mean a bit more complicated. Not quite so mean, not quite. Let me have a look. Lower quartile, absolutely. We do need one of them. Upper quartile, absolutely. Do also need one of them. What kind of range do you mean? Different kind of ranges. You don't quite need one for box plots, but you do need them for kind of analysing the box plots. A certain type of range. Median, absolutely perfect. And then max and min. Oop, uh-oh, I'm writing over my face. Let me move those. Yeah, perfect. An interquartile range for analysis. Don't need to put that on the diagram, but we will need it for later. And then max and min. And those are all our lines. Absolutely right. So we have lower quartile, upper quartile, median, max, and min. So all these numbers, rather nicer then, to put them all in order. So what is first the lower quartile? So you have a look at that. What do we get for the lower quartile? I'll put them in the max. Min and the max are easy. 52 and 75. All in order. Easy peasy. So let you work out for me the lower quartile. The lower quartile. Let me put down the max and the min first though. So 52. Oh gosh. This axis is not very nice, is it? Where is this going in? Up in. That's 52.5. Ugh, this is gross. So it must be, what, 0.5s? 51, 51.5, 52. Yeah, 0.5s. Ugh, it's kind of gross, huh? Okay, so one less than 0.5. Let's put that there then. I can go there. Yes, I can. I will do that, don't worry. So when we do lower quartile, upper quartile, we'll see what the people get for them. Lower quartile is essentially just a quarter of the way through the data. Lower quartile is a quarter of the way through. Upper quartile is a 3/4 of the way through the data. Median is halfway. So it's like judging it every quarter, essentially. So lower quartile is essentially minimum is at 0. And then you have lower quartile at a quarter, upper quartile at 3, median at half, upper quartile at 3 quartiles, and then max at like kind of 1 or 100% of all the numbers. So it goes up in a quarter, essentially. And then we have maximum, which is 75. That one's quite nice. I'll put that one, make sure it's a bit proportional. There, don't know why I've drawn it so low, but well, that'll do. Cool. Yes, so lower quartile is a quarter of the way through the data. Upper quartile is 3/4 of the way through the data. So the way I do this is add up all the numbers, which is 15. If it's odd, which is annoying, then just add 1. If you add 1 to it, you get 16. 16 divided by 4 is the 4th one along, which is 1, 2, 3, 4, which is 55. Using the formula 3, oh, that looks complicated. 3 lots of n plus 1 over 4. I mean, I guess maybe you can. But I like to just do, because then now you've got that one lower quartile, which is a quarter of the way through, just 4 in then from this end. 1, 2, 3, 4, which is 64. So you could use this, I suppose. But it's the simpler ways. So lower quartile is quarter of the way through, so 15, add 1, 16, quarter of that is 4. So then 4th one along, 55. And then 4 along then in the other direction will be 3/4, 64. And then, not necessarily, not always. It's just a quarter of the way through, yeah. So just, these aren't frequencies. The frequencies will be like 15 students essentially. It will be on a cumulative frequency diagram. That may be what you're thinking of. So then 55, let's put that there. And then we've got upper quartile 64, which will be this one here. Median. What's the median? What do we get for a median? What are we all thinking? What are we getting for the median? Am I working them out? So lower quartile is a quarter of the way through the data. So just a quarter of the way through. So there's 16 people, well, 15 people. We're going to add 1, make it easier. And to make 16 people, then a quarter of that, so times by a quarter, which is the same as dividing by 4. So 16 divided by 4 is the 4th person. So the 4th kind of person along, 1, 2, 3, 4, was 55. So we're going to do 55 essentially. Then upper quartile will be the 4th person in from the end, because it's like proportional either side. Or you can do 16 divided by 3/4, 16 times 3/4, which will be the same thing. So 4 in from the end, 64, so which is there. And then median, what I do for that, add 1, 16, because I like to cheat, and then half it, which is 8. So 1, 2, 3, 4, 5, 6, 7, 8, which is 60. And then that is that one there. And then all you do is connect all these bars up. So you should get something that looks a little bit like that. So you can, I know some students get a bit confused as to how big to have the bars and stuff, but as long as it's most things about sort of kind of just the aesthetic choice. I like to have all my bars being like roughly the same height, but you can have these ones a little bit shorter, these ones at like the ends, or you can have the box plot being short in the lines. It's just all aesthetic choice, really. So you can kind of do whatever you like, up to you. But that is a box plot. All there is to it. So a box plot, you need lower quartile, upper quartile, median, max, and min. Lower quartile, a quarter of the way through the data, so how many people you have times a quarter. Upper quartile, 3/4 of the way through the data, so how many people you have times 3/4. And then you have max and min, which is the highest and the lowest, and then median is halfway through your data. Which is to be out of about 3 marks. Normally it'll get you to do a bit more at the edge, the width of the box plot. No, you can make it as tall as you want, essentially. And obviously the actual like length of it has to be right, because it's has to be like between the upper quartile and lower quartile. So all these lines, I'll show you. So that's min, that's lower quartile, that's median. that's upper quartile, this line here, and then that's max. So all the lines always mean the same thing: min, lower quartile, median, upper quartile, max. This will be about 3 marks in your exam. This specific one, you have to find them, is 3 marks. They give you 2 marks just for plotting it when you already give you all the values, just for knowing where the box plot lives, and where to like put all the lines and stuff. So this will be 3, this question, maybe even 4, if they're being generous. It's quite a high reward question, box plots. They're little work but high reward if you remember what all the lines are. Does that all make sense? So min, lower quartile, median, upper quartile, max. Min and max, they're just the lowest number you have. So in this case, it's 54, or 52, sorry. That's the lowest number of seconds the students took to run the race, and the highest number of seconds was 75. Just the minimum value you have and the upper value you have. And that's that. How are we feeling? All feeling good? That's a box plot. All there is to them. And normally they'll just get you to draw one. That's all they'll get you to do. Just draw it. That's all they'll get you to do. Should I know this in year 10? It depends. Depends on what order you're taught in. Some people learn this in year 9, some people learn it in year 10, some people learn it in year 11. You need to know it all for year 11 at the end. So, I mean, you could learn it in year 9 or in year 10. So, there we are. Cool. Fun then. Okie dokie then. So, next thing we're going to look at is comparing box plots. So, they don't get you to draw one. They'll get you to compare them like this. So, compare the distribution of the heights of Maggie's plants with the distribution of the heights of Nigel's plants. So, it's just comparing heights of tomato plants, essentially. I'll make these graphs a bit bigger so you can see them a bit better. I'll also make them different colours because that's also might make it a bit easier to see them. So, these questions, if they come up, golden, right? Godsend, okay? Because they're normally 4 marks for comparing them properly, and it's always the same. They always want exactly the same things from you. Every time they need to compare the same 2 things, no matter what the context is, no matter what's happening in these box plots, it's always the exact 2 same things every time. Now, does anyone know what those 2 things are? I'm going to colour code these a bit better so we can see them. Put them in some, that one's not very bright, is that? I'm going to say brighter colours so you can see them better. Again, it's like the dingy grey back splash of it. So if this makes it better, having it in like yellow, I think that makes it worse, doesn't it? I don't know. But remember what they want us to compare. Hopefully you can see them. I think you roughly can. So I'm looking at it over here. It's where I can see the display. It's back over on the second monitor. So hopefully how you can see that. Median is different. Yes, perfect. So the first thing we need to compare is the median. Absolutely right. So median is the first thing. So an average, which is normally the median. Start of the hyperpivot, kind of midway through. Near maybe like 3/4 in. Something like that, maybe 2/3 in. Roughly around that point. Near the end, like kind of midway between the middle and the end, sort of. Perfect. So median is going to be the first thing. What else we need to talk about? And particularly either the interquartile range or just the normal range. Either or, both would do. Doesn't matter. Both would be fine. Either median or either interquartile range or the normal range. Up to you. Take your pick. And then why? Why are we comparing these things? Why are these the chosen 2? Why are we not comparing, I don't know, the lower quartiles? Why are we comparing the median and the ranges? What do they tell us about what's happening here? What do they tell us? Any ideas? What does the median show us and what does the interquartile range or the range tell us? Sort of with the box, sort of. Not quite. So what do these tell us? The data, numbers, the heights. Sort of. So something about the height. Yes, actually, Ariba, perfect. That is the word one of the words I'm looking for. Consistency. So we want to know how consistent the data is. So consistency is to do with the range or the interquartile range. We want to know how consistent the data is. So let me use a different. Whoopsie daisy. Let me get rid of this. There we are. Consistency. There we are. Just my Windows playing up. You know what I mean? Press the wrong button. Consistency. consistency. Oh, you can't see that. Let me move it. Let me shuffle it. Consistency. Perfect. So consistency will tell us, are all the heights around the same height, or are some plants really, really small, other plants really, really tall? Is there no consistency? Are they all very different heights, or are they all roughly the same height? That would be consistency. And then the median will show us about the overall average of the plants. So which group of plants is taller on average? That would be what that would tell us. So like the average heights. Okay. And then all we need to do then is put these into words with possibly a couple of numbers. That's what they mean. Not really what they mean, no. So they don't ask us exactly what everything meant in this box plot, but they just ask us essentially this question, word for word. Compare the distribution of the whatever context they're using with the distribution of whatever other context they're using. And that would be the question. So I've seen it many times with like scores, or with, I don't know, weights of animals, or with, I don't know, shoe size, I guess. Really anything. Anything could be. It's just the same question. Just compare the distribution. Whenever you see this phrase here, compare the distribution, always these. Median and then range, which is then average heights and consistency. So, what I will put for this question is, let's have a look. Who, on average, has who has the highest median out of these two? Whose median is the highest? Is it Nigel's, which is the top one? This is Nigel's. Or is it Maggie? Who, on average, has the tallest tomato plants? Have a look. Nigel? Yeah, perfect. Absolutely right. It's Nigel. So, what I would put is, on average, Nigel's... Oh, hang on. Wrong way around, aren't they? Silly me. Sorry about that. I've got the plants the wrong way around. Hang on. So you are all kind of technically both right, essentially. So this one is Maggie's, and this bottom one is Nigel's. Sorry about that. I got on the ones the wrong way around. And then this one is Maggie's. Oh, Nigel's. Sorry about that. Nigel's. Sorry. I need to read the question here. Having a frequency. That's histograms, Akila. That's histograms that you need those things for. That's a histogram. So not yet to know, because these are box plots and I need those for histograms. So on average, if I could type in here again, which doesn't look like I can. Yeah, I know. Silly me. Right. So on average, if the text box would behave, that'd be really handy. On average, Nigel has the tallest tomato plants as the median is higher. And then maybe put the numbers. Maggie has a median of, what is that, 35? And Nigel has a median of 25. That'd be that. Yeah, class width, frequency, density, that's histograms. You need those for. So not this, that's histograms. And then, next thing, so whose plants are more consistent? Whose plants' heights are more consistent? Whose plants are more consistently heighted? Don't think that's a phrase, but alas, oh well. Let's have a look. So I would do range for this just because I like range, I think. I don't know. So this is 55. Oop. 5, and that is about, what, 12? And this one is 55, 6, 7, 8. And this one is 5, 6, 7, 8. So this one has a range of 50. And this one has a range of 55 minus 12, whatever that may be. Again, mental maths, not my strongest suit. 43. Okie dokie then. So, Maggie's plants are more consistent. Absolutely right. So, Maggie's plants are more consistent because they're less spread out. So that's either or things you could say. So Maggie's plants are more consistent as the range is smaller, or Maggie's plants have heights that are less spread out because the range is more consistent. Oh, it's because I started writing. You are right. Sorry, Finn. You are absolutely right. Because I started writing it before I realised I switched them over. You are absolutely right. Gosh, can't type today, can I? Getting all flustered. Silly me. So there we are, yes. So, because I switched them over because I mixed them up, didn't I? I'd already written that bit after I mixed them up. I didn't realise I had to go back. But yes, so you work out the medians, just to summarise. I know I've made a bit of a butchery of this, haven't I? So just to summarise, you find out the medians. Whoever median is the higher, on average, they're doing better at the thing in the question, right? The context. So in this context, Maggie's got a higher median than Nigel, so her plants are taller. That's the first thing you would say. You compare the medians for whatever context they have. Then you work out consistency, so you work out the range or the interquartile range. Either of those would do. And then what you do is whatever number is then the smallest, they are more consistent. So you write that. And that would be guaranteed 4 marks. Or whatever, however many marks they've given you for this question. 3 or 4, either or. So you work out median, and then whichever median is the highest, they do better at the context, or whatever it may be. I don't know, better marks, better, taller, I don't know, better grades, whatever it may be in this context. Or then you work out the consistency, which is the range or the interquartile range, and then you say whichever one has the smallest is the most consistent. That will always be 4 marks, depends on the context. So saying like this context here, context of math scores, so you work out the median for both of them. Looks to me like the median for class B, which is the bottom one, is higher. So what you'd say would be for class B, the median is higher than for class A, therefore, on average, class A or class B scored better than class A. And then you work out the consistency, so the range looks to be slightly better for class B. I haven't worked out the exact number, but it seems to be, you'd work it out, you find the actual range, right? So you there then say for class B, the range is lower, therefore class B scores are more consistent. And that will always be 4 marks. 2 marks is for drawing the box plot. I just did that for you already. And there we are. Does that all make sense? And I kind of made a bit of a butchery of that on the last slide, getting all mixed up. Needed to read the question better. But does that make sense? Median and then range. Median for average, who does it better? And then range for consistency. Those are your 2 things you always bring up whenever you're comparing distributions. Range and for consistency and average for average. It was meant to end 7 minutes ago, but we're not really at the end yet, are we? So I've got this next hour free, so I don't really mind going over by a little bit, but hopefully that all makes sense to everyone. Grand. Perfect. So we're meant to do cumulative frequency graphs as well, but they're quite easy. They're not that bad, essentially. So we'll briefly look at them, but so we won't spend much time on them. So we're going to finish in the next time, probably like 10 minutes. Wait, what is the comparison for? So this question, this class one, so the median for class B is higher. As you can see, the line's a bit further on. So on average, class B scored better than class A. They had higher average score than class A, so that's what you'd say. And then the range looks slightly lower for class B than class A. Obviously, you may work it out and find that that's not true. Because I haven't worked it out. It's up to roughly the size of like how far along this looks. This wants to be slightly closer together, these end lines. So the range for class B is better. The range for class B is lower, I should say. Therefore, the class scores are more consistent. So that's what you'd say, Keela. So you'd say the median for class B is higher. Therefore, on average, they scored better. And so the range for class B is lower. Therefore, class B scores are more consistent. That will get you 4 marks. Maybe put in some numbers that you've grabbed from the graph as well. Back in so many numbers that you got from there. And then that'd be that. So that's how you do averages. Oh, well, that's how you do comparing distributions, I should say. Always the same. Always want the same stuff. Cool. I know I'm always going over, aren't I? I'm rubbish at timing. Don't know how good Fliss and Ketty are at it. I'm sure we know that I go over quite as much as I do. But I quite enjoy these tunes. I think they're quite fun. I quite like them. I don't mind going over. I've got nothing in this hour anyway. So I leave myself a free hour after these live streams to decompress before I start teaching again at 7. But Anyway, we'll have a brief look at cumulative frequency graphs and then we'll finish there. So, the one thing to remember with cumulative frequency graphs, or really any graphs, because there's a lot of them that are very similar, right? There's cumulative frequency, there's frequency polygons, there's histograms, there's loads of graphs that are all very similar, right? You have to remember which one is which, right? So, for cumulative frequency graphs, how do we plot a cumulative frequency graph? What do we need to plot against what? Obviously, frequency keeps pulling with frequency, but what is that? What is cumulative frequency? And then, what is this other column for here? Upper. It is indeed a Reba. Perfect. Upper value. So, the highest one in this range. So, upper value against the cumulative frequency. Frequency density is histograms. So very close. Histograms, you plot class width, because it's like a bar chart is a histogram. So a histogram is you plot class width, which is like the size of the bar, against frequency density. So that's for a histogram. A frequency polygon, that's midpoint against frequency. For a cumulative frequency graph, it's upper against cumulative frequency. I know, there's loads. There's so many, right? There's so many of them that you have to remember them all for. But histogram, frequency density with class width for bar charts. And then you have cumulative frequency graph, which is upper against cumulative frequency. And then frequency polygons, you have midpoint against frequency. I know, they're all very similar, I'm aware. So cumulative frequency should look something like a nice shape like that. Frequency polygon are like, you just connect the lines, so they look a bit like that. You just connect the points with straight lines. And histograms are like bar charts. Just all connected up, actually. So like that. That'd be like a histogram. So that'd be cumulative frequency, this one here. Frequency polygon, and then histogram. Then, yeah, upper value will be just the upper in the range. So that would be then 50, 60, 70, and 80 with the upper value. So is it really well doing it? So you do with a frequency polygon. You don't with a cumulative frequency graph. Frequency polygon you do. Cumulative frequency you don't. So it's going to make it be a smooth curve, going up like that. So the rulers you use for very little graphs. Straight line graphs, yes. Lines of best fit, yes, occasionally, sometimes, unless it's like a curve, but it should be a straight line. Frequency polygons, no. You use, yes, sorry, I should say. But then cumulative frequency graphs, no. You use a straight, just a curve. And then histograms, you use rulers for those too. So you use a ruler for frequency polygons, but you don't use them for complete cumulative frequency graphs. Totally different. So yeah, cumulative frequency then is just add all together. So 6 and then 6 plus 16, whatever that may be. Essentially just like a running total is a cumulative frequency graph. Just a running total. Then 22 plus then 28 for this one. Plus 28, which is 50. 50 plus 10, 16. Frequency polygon is essentially, it'll ask you just to plot a frequency polygon. It'll tell you what it is when it wants it, like this. To plot a cumulative frequency graph. So frequency polygon is just midpoint against frequency, and it's like you draw line to line, so it's a bit pointy. It's a frequency polygon. So yeah, those are the different types of graph. There's a couple more, I think, but those are the main ones: cumulative frequency, histogram, frequency polygon. Frequency polygons, you only come right at the beginning of the paper, normally question 2, question 3. I think they come up question 1 as before as well. Cumulative frequency, just a rolling total of all the numbers. So, like say 6 would be the first one, and then everything at this point which is less than 60, which is 6 plus 6, or 16 plus 6, so 22. And then this column is everything less than 70, which is this plus this plus this. And then this one's everything less than 80, which is this plus this plus this plus this. So cumulative frequency is just a rolling total, so everything that came before it, essentially. Sum of everything that came before it. Does that all make sense? So that is cumulative frequency. Just a sum up of everything that came before it. So 6 is the first one here. Then you add up the one next to it. So 16 and then plus 6, which was 22, I think. And then, let me double check that actually. Don't write myself, it was 22. And then 28 then plus 22. You just keep adding on the next line as you keep going, which is 50. And then 10 plus 50, which is 60. And that's cumulative frequency. That's all there is to it. I won't plot it, but it's going to look something like that, essentially, roughly. If it's like normally like an S-shape. So we're running out of time. But that's it. So that's all the maths I'm going to do today. If you have any other questions about the maths, then I'm happy to answer them. But I won't do any new maths today. So if you have any place you need to be, and I've run over by like 15 minutes. If you do have any place you need to be, then feel free to leave at this point. But hope you've all enjoyed. That's been my very rough explanation of all the averages, box plots, and cumulative frequency. You know, you think that yeah, you just add them. Yeah, you do. You do indeed just add them. You think that if I taught all day every day that I'd get quite good at explaining this stuff. I think it's the context of a live stream. I don't have anyone to bounce back off of, essentially. Akila, so do you think it's better to print past papers or to do them by looking at them on the web? It doesn't really matter. It depends on your, like, how you feel about it. So obviously, if you print off every past paper for every subject, you're going to be killing a lot of trees, right? You're going to kill a lot of trees. So it depends on how sustainable you wish to be, right? So if you wish to be more sustainable, then you can, like, look at and then just write it on paper. That's what I used to do. So read the exam paper off of something online, and then do the question like actually on paper, writing it down. I think it's easier than like trying to type out maths. It's gonna be a pain to do. That's what I would do. That's what I normally do. But if you wish to print them out, say if you say you're only going to do a couple of them, then feel free to print them out. Then you have them physically, and you can store them away and look at them later. Otherwise, if you do them on paper normally and then like have the paper online, you're gonna find it ages to not like to find it again, and you're gonna lose it. Hence, well, that's what from my experience, you lose it. Good question there. Depends on how sustainable you wish to be, Akila. How to find the median? So you do the same thing as a histogram. You look at so it goes up to 60, so the median will be about 30. So then you go on to 30, you then read along from it, wherever it hit the graph. Obviously, I haven't drawn the graph, and you go down from it. So wherever it hit the graph, 30, and then go down a bit. I hope, Nikila. Hope to see you next week too. That'd be nice. Cool. Any other questions before we leave? Before we drop off? Before I go make myself a cup of tea? Which steps will we get marks for in those? In the cumulative frequency graph, or in some of the other question? Looks blue. Because marks depend. Normally you get marks for plotting these sorts of lines here. So if the lines on a graph working, then that you get your marks for that. Normally you get a mark for having the right subject, like the right title headers, like page headers. That'd be, you get a mark for that. And then a correct mark for filling in the table correctly. And then a mark for plotting it correctly. And then this, working out the median, will probably be a separate question. It'll be a separate question. Does that make sense? So you get a mark for filling in these tables correctly. And then, because it was 3 marks altogether, so you get a mark for this, like the headers. You get a mark for filling in the table correctly, then you get a mark for drawing it correctly. No problem, everyone. Thank you all for coming. Hopefully see you all next week. And then finding the median will be a separate question. It'll be a separate question altogether, like a part B or something. Will that make sense? Any other questions? Anything else we wish to ask? Feel free. Well, I think I'll end, unless people don't have any questions, I'll probably end at like 20 past. But I'll stick around for a bit in case anyone has any other questions. Oh, no problem. I'm glad you enjoyed it. I always feel a bit rumbled after I do it, because I feel like I stutter a lot. And I know what I'm trying to say, but it never comes out quite right. You think it would, because I teach like all day, every day online. So I'm quite very used to this setup. I think it's just not having anyone's face to like bounce off of. I think it just makes it a bit weird. I don't know. But alas. I'm glad you all enjoyed anyway. Thank you all for coming. How did I plot it? Well, what you need to do is then just plot these numbers against each other. So you'd go so you start at like 50 and then go to 6. And then you just like plot it like these would be just coordinates. So you do like 50, 6, 60, 22, 70, 50, 80, 60. They just be coordinates. essentially. Which paper? Any of them. So there's not really set of things that are only paper 1, only paper 2, only paper 3, or only 4, 5, paper 4, 5, 6, like if you're OCR. Anything can really be on any paper, to be honest. Anything can be on any paper. Let's take exact trig. Exact trig is normally paper 1, and then trigonometry is normally paper 2 or paper 3. But if it's exact trig, paper 1. And then things like circles with pi, they tend to go from paper 2 and 3, but if they have to leave it in terms of pi, it could be in paper 1. So nothing is really exclusive to any of the papers. It's all a bit of a free-for-all. Anything can be anything, which makes it both really easy. You have to revise certain things for certain papers. You won't be normally will be better at one paper than the other, like paper 2 and paper 3 are so similar. So it works better in that regard, but then other regard is you have to learn everything for all the papers, which is something quite frustrating sometimes, but is what it is, is what it is. Let me get my face back, and then I'll put it on full screen for now, because I've kind of finished the maths now. You get my face in full and a jump scare again, but get my face in full again. Cool. Any other questions before we leave off? I've kept you all for much longer than I should have, but oh, no problem. I'll be happy to see you. Yeah, so next week I'll be doing, what did I say earlier? I can't remember. I think I was doing straight line graphs next week. Something like that. So I'll be happy to see you all later next week. Fliss, there's also other live streams happening this week if you all wish to come. It's not maths, I'm not going to be there. So Fliss is doing coding. She's just Python tomorrow at 5. So Tuesdays at 5 is Fliss. So Mondays at 5 is me, Olivia. Tuesdays at 5 is Fliss. And then Thursdays at 5, and Ketia does study skills, which is quite fun. Just goes through positivity, how to keep positive, and how to build a study schedule, and how to revise, things like that, which is quite helpful. He has really good PowerPoints and stuff. I watch his lectures, they're really nice. I watch Fliss's too sometimes, so I don't really code though. I'm not a big coder. The chair would suggest otherwise. I'm not much for coding. But yeah, feel free to go to any of the others as well. But yeah, I've no other questions then. I'm going to end it there. Thank you all so much for coming. Hope you've all gained something from this, even if it's just, that this girl talks too much. But hope you've all gained something from it. And hopefully I'll see you all next week. So have a lovely week until then. Have a fun week at school this week. Best of luck for mocks if you have them. And yeah, have a lovely week. And I'll see you next time. Thank you all.